Unit 7 is going to be about differentiability algebraically and implicit differentiation. So this piece right here is very short. There's only going to be 3 lessons on this. I just went ahead and squeezed it with implicit differentiation, which is going to be the bigger chunk of this unit. And so 7.1 is just talking about really what differentiability is. We've already learned what continuity is. Continuity is when a graph is one smooth, continuous line. There's no jumps, so we can't have any holes. We can't have asymptotes. We can't have jumps. So if something was here and then we did this, no breaks in the graph. That's continuity. Differentiability takes it one step further and says that actually the slopes have to be the same. So it has to be even smoother. So step 1 is it has to be continuous to even consider if it's differentiable. And then 2 is checking if the slopes are the same. And so what we're really back to doing is thinking limits, because we're looking from the left and from the right side. So these 2 graphs are what I drew. It's kind of hard to tell, but here at this x value, see how this is like a parabola and then a linear? This piece right here would mean it's not differentiable here. You can't take the derivative here because we've got a corner or a cusp where 2 different slopes are meeting up. Versus this one was even kind of hard to draw. I did a parabola and then kind of stopped and then continued on. This piecewise function would be differentiable because it's smooth, there's no corners cusp. The slope would be the same coming from the left and the right here. So here's the fancy definition that you'll see if you ever look at any of the stuff on Delta Math. Just saying that the function, when it approaches the value from the left and from the right, is the same. That's just checking, is it continuous? Is there, there's no holes and there's no jumps. And so we've done that before where we just plug the number in. And then step 2 is then now we're taking the derivative or the slope, plugging in a from the left and the right and seeing if the slopes are the same. So I would say are the slopes the same? Okay, so number 1, we just need to simply plug in 0. Easy enough. So first is check continuity. And I don't get all fancy with it. I just think, okay, this is the left piece since this is x is less than 0. Plug in 0, plug in 0. So this would get 17. Plug in 0 to the right-handed side. That would be 0 plus 13 is 13. That doesn't work. So as soon as I know it's not continuous, it can't even be differentiable. So this would be, it's not continuous and it's not differentiable. And then number 2, we're going to plug in, so check continuity is your step number 1. Plug in 7 here and 7 here and see if they get the same value. And they do. They both get negative 53. So that means it is definitely continuous. Now let's check for differentiability. I'm just going to abbreviate that long word. So then I'm taking the derivative of the left piece. So it'd be 2x minus 11. Derivative of the right piece is negative 7. Now plug in your x value where the break is happening. So 2 times 7 is 14 minus 11 is 3. 3 does not equal negative 7. So what we have decided is that this function is continuous, but it's not differentiable. The second one here will never be an option because it can't be just differentiable. It has to be continuous before differentiable. All right, and then this one, the only thing we're changing is now you're going to have either log functions or exponential with the base e. And so we just need to know how to take the derivative. But they are going to have these different boxes with the drop-down menu. So this is saying just find the limit from the left and the right. And we're going to plug in 1. Oh, shoot. Okay, I accidentally copied and pasted this wrong thing. So these actually should be 1s. I'm sorry. Okay, so plugging in 1. That would be 3 times natural log of 3 minus 2 is 1 plus 4. And so that's all you can do. Natural log is a button on your calculator. It can get a value, but we don't want to simplify it. So this is going to be hard to fit in there. Okay, and then the other piece would be Negative 2 times 1 squared plus 6, which is 4. And then the one where f is 1, that's the piece that has the equal to. So that would also get out 4. Now we're finding the derivative from the left side and the right side where the break is happening. So this is where our rules come into play. If I'm going to find the derivative of natural log, remember it's be 3 times 1 over that inner piece, but a chain rule applies. So I'll have times negative 2. And then the constant goes away. Okay, let's simplify that. So that would be 3 times negative 2 is negative 6 over 3 minus 2x. And we're plugging in 1. 2 times 1 is 2. 3 minus 2 is 1. So the slope coming from the left is negative 6. And then check this one. That would be negative 4x. Constant goes away, and we're just plugging in 1. So that slope is negative 4. So we have found out that because the left and the right-handed side of just a normal function did not approach the same value, there's some kind of jump discontinuity here. So it's not, I should probably put continuous or differentiable. So again, the difference would be if I had these two, or actually all three of these equaling the same number, that would say it's continuous. And then if the slopes were the same, that would be continuous and differentiable.